Good afternoon, Devanshu.
Good afternoon, sir.
How are you feeling?
सर खांसी का थोड़ा है, बाकी ठीक.
अच्छा, अभी तक ज्वाइन नहीं किया है ना?
ना सर, ज्वाइन किया बट आई डोंट स्पीक मच, लाइक आई स्टे मम.
ओके ओके, नहीं मैंने चलो कोई बात नहीं। ओके।
रिकवरी है सर पहले से, बट ये लाइक कोविड के वक्त पे नहीं थी खांसी, बाद में आ गई ऐसा.
अच्छा, वो एंटीबायोटिक की वजह से हुआ होगा।
यस प्रोबेबली.
मैंने भी कल वैक्सीन ली तो मेरा थोड़ा सा तबीयत ठीक नहीं है आज।
सर रेस्ट रेस्ट करिए सर.
हम्म, चलो थोड़ा कुछ डिस्कस कर लेते हैं आज। गुड आफ्टरनून दीपक। Okay, just give me a minute so we can start discussion. Since I'm also not feeling well, but we'll try to discuss some more points and I will give you task. Okay, you complete the task. I'll just try to go through the one of the research article where process modeling and simulation of fluidized bed reactor is discussed by the group of researchers. But still it is no, it is okay. This is the second one, so I will just go through it. So in the previous session, we had a discussion about CSTR, right? CSTR connected in a series, or CSTR number 1, number 2, and number 3, how the reactions are occurring and how we are getting the desired product, right? So for that purpose, mathematical representation is very, very important. Okay, mathematical equations. And that is how we are going for process modeling, simulation, and optimization. And in the previous class as well, we had a discussion about general methodology or steps involved in the process modeling. Okay, how to generalize it, that we have discussed. So my objective for the today's session is to deal with uh, fluidized catalytic cracking, FCC. Okay, it stands for fluidized catalytic cracking. And let's at the end of this session, students will be able to analyze FCC system, and you will be able to draft a report on dynamic process modeling. Okay, dynamic modeling and simulation. So just how to deal with that process modeling, since in the unit number 3 we are discussing about the different process modeling approaches for fluid flow, heat transfer, and mass transfer. So in fluidized catalytic cracking, we have all these processes where one can say one must develop the models, and it must be generalized in order to use in different industries. So in practice, there are many operations which is which is monitored and influenced by many factors. So one of them is, let's say, it's fluid, heat, and momentum related issues, right? So here, process modeling is very, very important. Okay? Because in process modeling, you have to deal with the parameters. Let me write it here. In the variables, parameters, and desired output, right? Desired output. So all these points we will try to discuss in today's session with the help of one research article by a group of Han and Chung. Okay, we'll discuss this with reference to Han and Chung. Okay, this is published in 2001, but this is a kind of base for us. Okay, this will be a kind of base for our study for dynamic simulation for the process modeling, right? I don't know how long I will be able to conduct this class. But let us try. Let us try. I will share this material with you all as well. Okay. You have to complete the task, right? So just me share that mm, PDF file with you. I hope this is visible to you now. Is it? Is this visible to you? Dynamic modeling and simulation of fluidized catalytic cracking process. Deepak, Devanshu.
Yes, yes, right.
Okay, thank you. Okay, so they are the faculty of applied chemistry from South Korea, and they have developed the detailed dynamic model for typical FCC unit. And very, very important, it consists of reactor, regenerator, and catalyst transfer lines. You might have studied that. Nowadays, we are in need of medical oxygen, and the catalyst. Can you name the catalyst required for the production of oxygen? Are you aware about that? Will you please write in the chat box if you are aware about it? Which is the catalyst that is used for the production of oxygen? Because production of oxygen, it is one of the simplest phenomena, but catalyst is very important, right? Is that zeolite? Is that zeolite? Yeah, you may explore it. You may explore it, right? So nowadays you might have heard that zeolite is being imported from European countries or some other countries in order to increase or production of oxygen, right? So there we want reactor, we want regenerator sometimes in order to produce the oxygen as well. So fluid catalytic cracking or fluidized catalytic cracking process is used in numerous applications. Okay, so you know that fluidized bed behavior. So it is multi-phase flow system, multi-phase system you can say, right? So creating models for such non-linear systems. These are non-linear systems, right? So these are trying to capture the non-linearity where the variables may not obey the path which is described, or it is not linear. You can understand. It is non-linear with small change, let's say increase or decrease in the one of the variable, there is a large change in the output. Okay, so this type of modeling is to be done in terms of dynamic modeling and simulation. There may be a lot of changes with respect to time. Variable will change and one must take care of those variables. So dynamic, you know that the steady state and unsteady state, that means dynamic. So dynamic modeling is quite difficult, even in terms of its mathematical models or combining that mathematical approach in order to simulate your system, right? So we will just try to find out that which how one can go with how one can start this process. Okay, so this is the research article which is published in journal Chemical Engineering Science. Okay, so just for your information, this is the name of that journal. 56 is the volume. This is year of publication and number of pages. Yeah, number of pages. Let's say from 1951 to 1971. Okay, so it consists of almost 20 pages, 21 pages, right? So here it is very important to deal with the fluidized catalytic cracking process, since it consists of reactor, regenerator, and catalyst. I'm not sure whether I have shown you my um, simulation which I did for my PhD thesis. So that is liquid solid circulating fluidized bed, and there that is also a non-linear system. And yes, everywhere fluidization it plays an important role in order to get the desired, let's say, process outcome, right? So let us see. They here a distributed parameter model is presented for the reactor riser to predict the distribution of catalyst and gas phase velocities, the molar concentration of four lump spaces, and the temperature. Okay, so we used to say that variables are very important. Input variables. Okay, so here they try to cover these aspects. Okay, so as you know, the every research article it starts with the introduction. So they have mentioned about FCC. Okay, so it is a unit that converts heavy distillates like a gas, oil, or residues to gasoline and middle distillates using cracking catalysts. Okay, so everything is mentioned here. Okay, and it is also mentioned, that is what I have discussed with all of you sometime before. Okay, that FCC processes are known to be very difficult to model because the large process scale, complicated hydrodynamics, and complex kinetics of both cracking and coke burning reactions. Okay, so there are a number of research articles are available where a lot of work has been carried out by different researchers. Okay, and dynamic models is also studied by many authors, right? So here this in this article they try to present the model solver. Okay, and please do remember, whenever you will read the research article, the last paragraph of introduction section it gives you idea about what exactly work that has been done by that particular group. Okay, so please do remember, while reading the research article, the last paragraph of introduction section will give you overall idea about the work that is presented in that particular paper. Okay, so here they have mentioned like hydrodynamics. They have studied, I think, hydrodynamics as well. Okay, and as we have discussed, catalyst, molar concentration, four lump spaces, and temperature. Okay, and they even tried for the steady state as well as dynamic simulations using developed model, and that they have presented in their part 2 second paper. So here just we'll try to go through the first part of process modeling. So what is very important, as already we have discussed in the previous session, that when you are going for process modeling and simulation, you must be aware about your problem statement, then try to draw the schematic representation, right? That is the second step, and that schematics present representation must be simplified. That must be in the simplified version in terms of the configuration, right? So it may be in terms of reactors or regenerators, right? And then you will go with your assumptions, then you will put your, based on your assumptions, you will go with either it falls under the category of energy equations or steady state equation, mass balance, energy balance, momentum balance, or some other fluid related properties. Okay, so here in this article, the group of researchers, they are interested in looking for the FCC unit, which is comprises of a reactor and a regenerator that is joined by two catalyst transport lines. Okay, so very important is you have to draw the schematic representation, but before that you must know about the system. So this is in terms of physico-chemical phenomena that takes place in that FCC unit. Okay, there will be the cracking reaction. You know about that FCC is used for the cracking and coking, and the hydrocarbon feed like vacuum gas oil is injected into the bottom of the riser along with a small amount of steam. So the amount of steam is around 0.5 to 3 weight% of feed. Okay, so this is the schematic diagram of side by side FCC unit. Okay, so see, this is a kind of complex geometry. This is a regenerator, this is a reactor. Since we are discussing in terms of its catalyst formation or catalyst regeneration, so you can say this is a riser, this is your regenerator, this is the air supply, and here you have, this is air line, and here there is air distributor. Okay, and from the bottom, as I told you earlier, feed will be given to the riser. Okay, and this is sweeper or sweeping steam, then cyclone is provided. Okay, and you can take out your desired product, right? So in this paper, let's say they have given all these parameters what they want to do, right? But very important is they have mentioned actually in the last paragraph here. See, the modeling is concentrated on the reactor, regenerator, and catalyst transport lines. Okay, so this is catalyst transport lines number 1 and number 2. This is spent catalyst and this regenerated catalyst. How we can use or reuse the catalyst. Okay, so in this paper they have discussed in terms of reactor, regenerator, and catalyst transport lines. Okay, so there are some auxiliary units as well, like air blower, expander, wet gas compressor, feed preheater, air heater, catalyst cooler, CO boiler, and so on. Okay, so structure and features, then assumptions, everything they have mentioned in their appendix. We'll try to explore it. I think I have not downloaded it, but I will ask you as a part of your task in this class, you please go through it and try to download it. Okay, so let's say this is how they have simplified the diagram. Okay, now you may see that how difficult it is dealing with the process modeling, simulation and optimization. It's quite difficult. Okay? That's why there are many MNCs, they are charging much more for doing these kind of work. And how the people they are getting good salary, because it's difficult to perform the operations. Okay, so this is the kind of simplified representation for the reactor model, right? So in the earlier class we had a discussion about CSTR and some other processes, where even we have seen that like C0, T0, V0, these are our parameters initially and what will be the changes after some time. Similarly here for this reactor, like all the combination of what is coming in, what is going out, that is represented here. Its quantity, temperature, flow rate, catalyst concentration, let's say, or the concentration specific, whatever it may be, it is mentioned here. Okay, so for the riser, it is considered to be tubular reactor model. Feed vaporization section, it is a kind of junction model. And for disengaging stripping section, it is CST along with the reactor segments. Okay, so this is how you have to deal with one of the reactor. If you are dealing with the process modeling and simulation, you have to break down the information into the pieces, right? And what is going in, that must be specified at every part, otherwise you will not able to work specifically at this point of time. Okay, so this is schematic diagram for the reactor model, right? Next, what you have to do now, right? Now you have to take the different sections separately. You may take the different sections separately, try to work on it and get the desired results. Okay, so let's say here maybe it depends upon the different variables, like you can say the temperature, pressure, velocity of the vapor and catalyst coming out of the vaporization section. So these are calculated by this group of researchers. Okay, and they mentioned like you have to give the support to your whatever you have mentioned in your research article. So he has mentioned, or the authors they have mentioned, like whatever the assumption they have, like the feed vaporizes instantly upon contacting the hot catalyst. So this is one of the assumption. Okay, this is one of the assumption, right? So within 0.1 seconds, it has been worked, right? So there are many uh, let's say postulates or assumptions we need to consider, and you have to support them with the help of earlier articles, those which are published, or if you are having your own postulates or assumptions, you have to create a kind of support data for it. Okay, so see here in figure number 3, this is the profile of gas oil conversion calculated with and without momentum equations, correct? And in the figure number 4, this is 4 lump model for gas oil cracking reactions. Okay, so you please go through it. So the reactor riser. So these are the assumptions here. So this is one dimensional tubular reactor with radial and axial dispersion. Okay, and you can assume, you can go with the momentum, mass and energy balance equations. Okay, maybe in terms of catalyst phase and the gas phase And these are the six assumptions they have used. Like the cracking reactions only takes place in the riser. The riser wall is adiabatic. Dispersion and adsorption inside the catalyst particles are negligible. Now you may consider that while looking at these assumptions, you can alter your equations. The equation may be related to the heat, mass, and momentum. Okay, these are related to the heat, mass, and momentum. So it is also mentioned that same properties for the catalyst and whatever the uh, input you have. Okay, and it is also mentioned that the coke deposited on the catalyst does not affect the fluid flow. So you can go with your assumptions, but make sure that the assumption whichever you are considering that must applicable to your system. Otherwise, it won't work. Okay, otherwise it won't work. So yes, you may go with the momentum equation. You may not use a momentum equation. Okay, you have to deal with the properties of that catalyst or gas phase. It's such as like velocities, volume fraction, density, pressure. Okay, and for that you may deal with the momentum equation, right? So see, now it started. The actual working has started now. Now you can see there are a lot of equations. Okay, so catalyst activation, deactivation, then feedstock composition. So how we have to combine all these things, okay, and how to deal with them, how to combine them, that must be carried out. So now this is the second approach for the schematic diagram of regenerated. The first one was the reactor, and now this is for the regenerated. Okay, so regenerated cyclones, it is considered to be continuous stir tank model. Already we have discussed about it in our previous session. Okay, so here you can see that there are number of okay, so whatever may be the chemical reaction or chemical compounds or hydrocarbons, those are applicable to that particular reactor or regenerator. You have to take care of all these reactions and its supported, let's say, data. Okay, so this is mentioned here, this is mentioned here, right? So right now I am not going in detail, and very important is degrees of freedom. I think we have not discussed this, but degrees of freedom analysis is very important when you are going for the numerical algorithm. Okay, and this must be given, right? So number of unknown variables, what are, and how many equations will be there, so everything will be studied with the help of degrees of freedom analysis. Okay, so this is how one can go with, and they have used non-linear algebraic equation or its hybrid one routine of mean pack. This is one of the software they have used in 2001 to deal with or to solve this FCC unit for the process modeling, for the dynamic modeling. Okay, so now this is the information flow between the models, how the information will flow. So how the equations will corresponds to the output of the system with change in the input values. So you have mass and heat equations, momentum equation, okay, and the other equation if it is there, right? And this is modular iteration scheme for the convergence. Convergence, it is nothing but the finding out the suitable solution with minimum error. Okay, so there are n number of models you can use to calculate your desired values, and the iterations will be in terms of unless and until you will get your final product, or let's say less error. So you have to continue, you have to um, get the desired output. Okay, so these are the notations and all these things whatever they have mentioned. I think they have given the, yeah, it is here, see the appendix, process model equations. So these are for the fluid vaporization section. right? The reactor riser, disengaging stripping section, reactor cyclone. So these are the equations associated with this work. Okay, so you are requested to go through it. I'm going to share this article with all of you in the chat box if it is possible now. This is for your information. I have mentioned, yeah, it is here. This is the article. Okay, this is fluidized catalytic cracking. So I'm just trying to share this with all of you. Will you be able to download this from chat box? Just hang it. Can you see the new message in your chat box? Will you be able to download this? Please let me know.
Sir, it is not there in our chat box right now.
Okay. So what I will do, I will try to share this in your Canvas portal in the same.
Okay, sir.
Yeah, and even in your MU portal as well. So you please go through it and try to analyze the content, whatever we have discussed. Okay. So that's it for today's session. We'll meet in the next session with the same link. Till the time, take care and bye bye.
Thank you, sir.
Thank you, sir. Take care, sir.
Thank you.